Okay, gee, it seems like forever since I've made a video for all of you. I hope that this video finds each of you well and healthy, and we are really just on the home stretch here, everybody. Just a couple sections here to cover at the end of chapter, I guess this is the middle of chapter 12, law signs, law of cosines. We will then have a test over those two sections and then just kind of wrap things up here for the year. Okay, so looking at this worksheet, I know Mrs. Pinion had done the video over this lesson, law of sines. I'm going to just give you a quick kind of in a nutshell type thing. The law of sines is, when it's given to you, it's always expressed as these three fractions set equal to each other. But in reality, when you're doing problems, you are only setting two of these three fractions equal to each other. Okay, I think the key is make sure that after the trig function sine, that is the capital letter, which has to be the angle measure. And then in the denominator is the lowercase letter that's actually the side length that's opposite the angle that you referenced in the numerator. Okay, so here's what you need to do for all of these problems. This is really, really important. You have to draw these pictures and you need to label them. So for number 2, the question is, if you had triangle ABC, and angle A was 60 degrees, side A was 15 units, and side B was 24 units, could there be any triangles that could be made with that information? Only one triangle, or is it possible that there could be two completely different triangles with these same three pieces of information in it, okay? So that's what we're after. And so you don't really know at the beginning what the answer to that is until you kind of get into the problem. You're just going to draw a picture of a triangle. It does not matter whether your triangle is drawn to scale. Label the vertices ABC, then go ahead and label the given information onto the picture, okay? And you'll notice as I'm labeling this, I'm consistent with labeling angle A as 60 and then this lowercase a, 15, that is the side opposite angle A, and lowercase b would then be the side here, which is opposite angle B. Okay, those are the three pieces of information. And right now, I don't know even if it's possible to make a triangle with these particular dimensions and angles and things like that, okay? So you're just going to start by diving into the law of sines and see where this takes you. See a couple of tips that I also have kind of labeled on this screen here. One, and this is super important, your calculator has to be in degree mode. And unfortunately, degree mode is not the default mode. So you want to make sure you press that mode button on your calculator. And I think that it's maybe the 4th line down. The default mode is actually radian mode. And all of these problems, our angles are going to be in degrees. You have to make sure that's in degree mode or you're just going to get all the wrong answers. So if your calculator happens to die in terms of the batteries or something like that, anytime it resets itself back to radian mode, okay? So if when you watch the video, you probably heard Mrs. Pinion reference that you're looking for what she called a strong ratio. And a strong ratio is when you know a angle and then you also know the side opposite that angle. And so in this picture, we can see we know angle A is 60 degrees. So I'm going to put that in the numerator, sine of 60. And then we know side A is 15, so I'm going to put that in the denominator. Now, if I look at the other information I'm given in this problem, my hands are kind of tied because I don't know anything about angle C or side C. Remember, these are not necessarily right triangles, so do not assume that one of the angles is 90 degrees, okay? So kind of Pythagorean theorem's off the table because we don't necessarily know that. So me using angle C or side C would not be beneficial at all in this second fraction because I don't want to use two places where I'm going to have variables. Of the 4 sections, when you're setting up your proportion, you want to know 3 of those 4 pieces so you can solve for the 4th piece. So if we look closer, we can see, well, we don't know angle B, but I certainly know side B is 24. And so this is actually the only way to start this particular problem, is to start here with sine 60 over 15 equals sine of angle B over 24. You're going to proceed to cross multiply. Okay, that's going to be 24 times sine of 60. I'm going to set that equal to 15 times sine of angle B. Okay, now here's the thing. We are solving for an angle. Okay, so ultimately, when you solve for an angle, okay, an angle, you use the inverse trig buttons. Okay, those are the buttons that have the little like tangent -1, sine -1, cosine -1, which obviously, since this is law of sines, you know, we would be using the inverse sine button. Okay, but before I do that, I need to get rid of this 15 that's in front of sine B. Okay, so I'm going to get this so that at least just sine B is the only thing on one side by itself. I'm also I'll go ahead and type into the calculator 24 sine 60 divided by 15. But I would want to keep this whole decimal on my calculator screen. I'm just writing down on the paper for you guys that roughly comes out to 1.39, but I'm actually seeing on my screen 1.38564. It keeps going on and on and on. Okay, now here's where we can actually get angle B. What you're going to do to break the trig function sine off of angle B is you're going to do the inverse sine. Okay, and what we do to one side, we know we have to do to the other side. So when I do inverse sine there, that leaves me with angle B only. And then when I type in inverse sine, and I'm going to use that second answer feature, okay, what I end up getting is I end up seeing on my calculator the word error domain. Okay, now if this happens and you're getting an error when you're working through this, here's what that means, everybody. It means there is not any way that you could make a triangle that had a 60-degree angle here, 15 units across from that, and then over here on this side, 24. Okay, that can't happen. If you were to try to like construct that, it's not possible. So when it's kind of easy to figure out when there's no triangles possible, because then you just get an error. And so then we've got all this work here, which you would want to show that so I can see, okay, this is what you arrived at. And then you're just simply going to say 0. I'm just going to draw a picture of 0 triangles possible. Okay, it certainly would not be acceptable for you to write down 0 triangles possible and not have the picture labeled, show that you started the law of sines. You can't arrive at this unless you do these calculations to know that there's no triangles possible. Okay, now here's a tip I'm going to give you. We're going to look at one other one. We'll do this next one a little bit faster here, but if you ever have the choice, and sometimes you don't, but if you ever have the choice of finding missing sides or angles, and you can go about finding pieces in a different order, you would always want to follow the strategy of trying to find the largest side or angle first, and then work your way down to finding the smallest side. Again, on this problem, we didn't have a choice, and maybe this tip is more helpful with law of cosines that you're going to be learning early next week. We're going to take a look at number 4. Directions were similar. They're asking us to try to figure out, like, okay, how many triangles could you make from this? So let's go ahead and jump in. I'm going to draw a picture of triangle ABC. I'm going to then label onto the picture angle A is 34 degrees, side A is 8, and side B is 13. Okay, then I'm going to proceed to set up law of sines. I can see here's my strong ratio right there. So I'm going to do sine of 34 over the side opposite, which is 8. And again, on this one, I have no choice. I have to find angle B first because I know side B. I would not want to do anything with side C at this point because I don't know either angle A or side A. Okay, so I'm going to set up sine of angle B over side B. Okay, remember what we did on the other problem? We cross multiplied here. Okay, so we're going to show how that looks. Okay. Very important that you guys are showing your steps, you're showing your work. Okay, that's how you show that you know actually how to do this. Okay. So you would enter, as long as you're in degree mode, you would type into your calculator 13 times sine of 34, divide that by 8. Now, for the purposes of writing things down on your paper, you can round it to 2 places, but then when you do the next step and you do like the inverse sine, I don't want you to take the inverse sine of 0.91. I want you to do the inverse sine of, and then use like that second answer feature where you're because I think this number is technically 0.9086. It keeps going on and on and on. Okay, so I'm going to do inverse sine. Second answer is when you hit second and the negative key, by the way. I think we've used that before in class. Okay, and then it did ask you, I think, that you're just going to round the angles all the way up to the nearest degree. Okay, so you don't need to carry it out to any decimal places. This comes out to 65 degrees for angle B. Okay, so I'm going to add that to my picture. Okay, now there was this special case that Mrs. Pinion talked about. It's called the ambiguous case, and it's when you are given 2 sides that are right next to each other and then an angle not included in between those 2 sides. This is the only situation where you could have no triangles, 1 triangle, or 2 triangles. Okay, so here would be my recommendation to you. As soon as you get the first angle, so we know for sure that we can eliminate that there's not going to be no triangles because we didn't get that error like we did in problem number 2. Okay, what I would recommend you do right now is just kind of create a second column on your paper. Go ahead and draw a second triangle as if we're thinking a second one might exist. Go ahead and label on that picture all the given information that was in the problem. Okay, but, and I'm going to highlight this, the angle you got here as 65 degrees for angle B, if there is a second triangle, that angle is always going to be 180 minus the angle you first found. Okay, it's like, it's always going to be, I'm going to write down here, it's always, we call that supplementary to the first angle. Okay, so an angle that would be supplementary to 65 is 115. So I'm going to go ahead and fill 115 in here. Okay, and here's what you would then want to look at. You would want to say to yourself, now, I know there's 180 degrees in a triangle. Is there enough space, if this is 115 and this top angle here is 34, for there to still be enough degrees left over for angle C to have a measurement? Okay, so if I add together 115 and 34, I end up getting 149, okay, which that's not 180. So if I subtract off 149 from 180, that leaves me an extra 31 degrees for angle C. So you see there's 2 spots here for our first triangle and our second triangle. I'm going to go ahead and fill in angle B in the second triangle's 115. I just found angle C in the second triangle. Okay, and I'm going to back up over here to my first triangle. It'd be easy to find angle C as well. We would want to add 34 and 65 together. Okay, 34 and 65 both add up to 99. So if I take 180 minus 99, I get angle C in the first triangle to be 81 degrees. Okay, very important as you guys are drawing these pictures that as you find these missing pieces, sides, and angles, add them to your picture. Okay, so for both of these pictures, all that we have left to do is we just need to do the law of sines one more time, and I'm going to fill this space up underneath here to find side C. Okay, so let's go back and look at the first picture here. I want side C. I'm going to stick with the first ratio I had. That was the strong ratio of sine 34 over 8. I'm going to set that equal to sine of 81 over side C. And then when I come over to my other triangle over here on the right, same thing. I'm going to start with that strong ratio, sine of 34 over 8, but set that equal to sine of 31 over C. Okay, and then all I have left to do is I'm just simply going to cross multiply. Okay, in both of these scenarios, I'm cross multiplying. And then I'm not finding an angle, so I'm not going to use the inverse trig button. I'm just going to divide by sine of 34 from both sides there. And over here, same thing. I would divide by sine of 34. Okay, and on the calculator, we would punch in both of these things here. 8 sine of 81 divided by sine of 34. And I think that you're supposed to label your sides out to 2 places. Over here, I think this was 7.37, so I'm just going to add that onto the blank, and I'm just going to throw it on the picture so that the pictures are completely labeled, and we completely solved the triangle. Okay, hopefully that helps.